Test question on antiderivatives. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to share a very important test question on application of antiderivatives to find the integrals. The question here is, find dy dx of sine cube 2x and hence evaluate definite integral from 0 to pi by 4 of sine squared 2x cos 2x dx. And part B is definite integral from 0 to pi by 4 of cos cube 2x dx. Let me thank all the viewers and subscribers for watching my videos and sharing such questions. Now let us see, how do we do such questions? So as the hint is already given to us that we need to find the derivative, that is dy dx of sine cube 2x, right? That should help us to find the integral. So what is the derivative of this? Well, 3 times sine squared 2x times derivative of inside function, which is sine 2x derivative, which is cos 2x, times derivative of 2x, right, which is 2. So multiplying, we get 6 sine squared 2x, that is 2x, right, sine squared 2x cos 2x. So that becomes the derivative of sine cube 2x. Now it means that if I do the integral of 6 sine squared 2x cos 2x, I should get sine cube 2x plus constant c, right? And that's what part A is, right? Exactly, perfect. So now let's write down what part A is. Part A, we need to find the integral from 0 to pi by 4 for sine square 2x cos 2x dx. So you can see here that we have 6 times sine squared 2x dx, right? So the derivative for that is sine cube 2x. But here we have sine squared 2x cos 2x, not that number 6, right? So what you could do is that you could multiply and divide by 6. It doesn't really make a difference. It's a constant, right? So we can multiply by 6 and we can also divide by 6. The same integral. It is the same thing, right? However, now you can see that the integral of inside function, because 1 over 6 is a constant, will be what? So 1 over 6 remains here, right? And the integral is sine cube 2x, correct? You get the idea? So we get sine cube 2x from 0 to pi by 4. So which is, we'll now plug in pi by 4 for 2x. See, I'm not writing constant c because it gets, when you subtract, then c minus c becomes 0, right? So this gives you 1 over 6 sine cube of 2 times pi by 4, right? Minus sine cube of 2 times 0, right? Which is 0, right? So sine pi by 2 cube, right? So that gives you the value of 1 by 6, correct? Because we know sine of pi by 2 is 1 and cube of 1 is 1, right? So we get our answer 1 by 6 for part A. Is this clear to you? right? Now, let's continue and find the solution of part B. Part B for us is 0 to pi by 4. We need to find the integral cos cube 2x. Now, in this particular case, 0 to pi by 4, we need to find cos cube x, cos cube 2x, right? You could write this as 0 to pi by 4 cos 2x times cos square 2x. Correct? So we'll just work with this trigonometric expression, simplify it a bit, right? Get it in terms of sine now. Cos square 2x is 1 minus sine square 2x, right? And if you further open this, we get 0 to pi by 4. Let's open it. So we get cos 2x minus sine square 2x cos 2x, right? Dx. Now we have already seen in part A that the integral of sine square 2x cos 2x is what, right? We know that now, right? So we just did that the integral of part A, sine square 2x cos 2x dx, is basically equal to sine cube 1/6 of sine cube 2x, right? So we can rewrite this as definite integral. Cos 2x integral is sine 2x divided by 2, right? Minus, this is 1/6 of sine cube 2x and 0 to pi by 4. Make sense? Correct? So that is how we can actually find the integral of cos cube 2x. Now we'll substitute pi by 4 and 0 to get the answer, right? So when I substitute pi by 4 here, then what do we get? So let's substitute that. Let me write down here, which is sine pi by 2, pi by 4, when you do 2 times, we get sine pi by 2 over 2, right? And here we get minus 1/6 of sine cube pi by 2, right? So all this minus, let's put 0 here now. So we get sine 0 over 2, right? Minus 1/6 of sine cube 0. Perfect. Sine 0 is 0. So with that, we get sine pi by 2, as you know, is 1, right? So we get half minus 1/6. Now half minus 1/6, taking common denominator 6, gives you 3 minus 1, which is 2 over 6, right? So 2 over 6 is equal to 1, right? So we get 2 over 6 or equal to 1 over 3, correct? So we know this integral is 1 over 3. So that is how we can actually find the integral of the particular trigonometric function. Perfect. So I hope the steps are absolutely clear to you. So to begin with, we found the derivative of sine cube 2x, and using the concept of antiderivatives, we found both the integrals. I hope you understand and appreciate it. Feel free to write your comments and share your views. In case you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.